Assalamu alaikum. Assalamu alaikum. How are you all? I welcome you to the first class that we are going to have together. And how was your paper yesterday, by the way? The paper that you took, the exam, was it fine? How many of you found the paper difficult? You found it difficult? How many of you could solve questions from motion? You could? You could do that? Okay, mashallah. Okay, so what I have decided is the first thing that we are going to take is motion in one dimension. Okay? That is something that you already studied in grade 9, I think, right? Have you done it? So what we will be doing is solving more problems so that we become aware of what exactly and how exactly will we face numerical challenges, okay, and practical problems. Is that fine?
Yes.
Okay. So this is my YouTube channel as well. You can ask me questions anytime if you feel like. Sometimes there may be any difficulty, and you're free to communicate through this channel, okay? So what we will be doing is motion in one dimension. Now if I ask you guys, can anyone tell me what is motion? Yes? What do you understand by the concept of motion?
Something moving.
Something moving, okay. Is moon in motion?
Yes.
Is earth in motion?
Yes.
Okay. If earth is in motion, then what are you? What is this class? Are we in motion? We are in motion.
You are not. You are something.
Now, we are not in motion?
There
Now,
has to be displacement.
Yes?
There has to be displacement.
There has to be displacement. He said, Mohit said that earth is in motion, right?
Spins.
But that is still motion, right?
Yeah.
So if earth is in motion, then we are supposed to be in motion, right?
Yes.
So are we in motion right now?
Yes.
But there is no displacement. See, what you need to understand is that when you talk about motion is not an absolute term. We cannot say whether a body is in motion or is it at rest. There are two things. One is motion and the other thing is what? Now, motion and rest, they are not absolute terms. They are not absolute terms. Absolute means we cannot be clear about the fact whether a body is in motion or is it at rest. We cannot say that. Why? Because these terms are relative terms. What are they? What are they? Yes? They are relative terms. What do you mean by relative terms? Anyone?
Change. They change.
No. Interact. Don't write down things. I'll give you the PDF. You need to interact with me. Talk to me. That's how we can make this class very interesting. I don't want you to keep quiet. Okay? So what do you mean by relative terms? Yes?
If one changes, the other changes.
If one changes the other, anyone else? See, understand, I'll tell you. Whenever we talk about relative terms, these terms are defined with respect to something called as the frame of reference. What? Frame of? What is frame of reference? Frame of reference is a place where an observer sits and observes motion. Is that fine? For example, you are inside a car. Understand what I am trying to say. You are inside a car. You are on the back seat, okay? Is the driver in motion with respect to you? Is the driver in motion with respect to you?
No.
No. Why? Because whenever you look at the driver is always in front, right? His displacement did not change, his position did not change with time. He was fixed. Is that okay?
Yes.
So when the driver was fixed, you always saw the driver here. For you, driver is at rest. Understand what I'm trying to say? For you, driver is at? He's at rest. Because with respect to you, you are the origin, you are the frame of reference, you are the observer. With respect to you, the position of the points in the body of driver have not changed. They are always there. Whenever you looked at him, he was always here. Is that okay? But when you look outside, you look at a building, okay? That building, in the first moment when you look, it was here. It was absolutely on your right. But after some time, you had to rotate your neck a little more, then only you could see the building, isn't it? So with respect to you, that building is in motion. Rest and motion are not absolute terms, they are relative terms. For a person who is on the ground, whenever he looks at the building is always there, isn't it? For him, that building is at rest. But for a person who is inside a car, that building is going backwards, isn't it? If you are going north, okay, that building is going south, isn't it? But for you do not assume yourself to be in motion. Why? Because you are the observer. You are the frame of reference. Is that clear? So when you assume yourself to be the observer, for you, everything comes to rest. And rest is in motion. So for you, that building is in motion, that fuel station is in motion, other cars are in motion, okay? But for you, you are at rest. Understand? Now, let us talk about an observer who is outside your car. The car is passing like this, okay? This is your car, it's going like this. Now, an observer on ground looks at your car and the car was here. Is that fine? But after some time, your car is here, isn't it? For him, for an observer who is on the ground, he sees your car changing its position, isn't it?
Yes.
For you, your car was at rest because you always saw your car in front of you. But for an observer who is on the ground, your car is in motion, isn't it? So what do we observe? We observe when the frame of reference changes, a same body, a single body can be at rest. It can also be in motion at the same time. With respect to me, we all are at rest, isn't it? But if there is an observer on moon, for him, all of us are in. Why? Because the earth is rotating. Is that fine? Is that fine? So what do we observe? Yes? What do we observe? We observe that when we talk about rest and motion, they are not absolute terms. They are relative parameters. They are dependent on something, and that something is called as frame of reference. Is that clear?
Yes.
What is frame of reference? Yes? It is the place. It's a place. It is a place where an observer sits and observes. Is that fine? Is that fine?
Yes.
Is it clear? Do you have any doubt in this? Now tell me. There is a car, we are looking out of this window, and there is a car which is moving. With respect to us, with respect to this room, this is the frame of reference. This is the place where we are sitting and we are observing, okay? Is the car in motion? Yes, it is. But with respect to the person inside the car, is the car in motion? No. With respect to that person, we are in motion. goes forward, and he doesn't assume that he is in motion. He says that this building is going back. Is that clear? So whenever the frame of reference changes, a single entity can be simultaneously at rest as well as in motion. Is that clear? So frame of reference is very important. Frame of reference is very important. With respect to us, we see the plane is moving, isn't it? But at the same time, all the passengers in the plane, is the plane in motion? It never feels to be in motion. For them, the plane is at rest. Why? Because the plane was always this room was always like this, and whole of it is in moving. Like I asked him, is Earth in motion? Yes, it is in motion. Not with respect to us. If the Earth was in motion with respect to us, then this floor would not be there. It would just change its position. Is that fine? But Earth is in motion with respect to a person who is on moon, who is outside Earth. Do you understand? Is that clear? That is the concept of frame of reference. Is it clear? So frame of reference is very important while we are describing motion. Now what we are doing is, we are taking up the concept of this motion. That means position is going to change, position will change, but it will change in only one dimension. What do you understand by one dimension? Yes? How many dimensions do you know?
3, 4.
3?
4.
Which is the fourth dimension?
So we can't perceive it, that's all.
That's different. So in the Cartesian coordinate system, we have 3 dimensions, right? We have the x-axis, we have the y-axis, and then we have the z-axis, isn't it? It's like something like this.
Yes.
X, Y, and Z. Is that fine? Remember, very important. If out of these 3, only one changes. If out of these 3, only one changes, we say that the body is in motion, okay? And it is in one dimensional motion. Is that clear? But what is the condition? Yes? Write it down. Out of the 3 coordinates, when only one coordinate changes, the body is said to be in one dimensional motion. Out of the 3 coordinates, if only one coordinate changes, the body is said to be in one dimensional motion. The body is said to be in one dimensional motion. Is that fine? Is it clear? Okay. Now, look at me. Am I in motion? Yes? But for me, I am not in motion. You are in motion. Is that clear? Why? Because I made myself the frame of reference. Now, when I am here, I feel like you are going there. So, you are in motion. So, frame of reference, write it down. What is frame of reference? It's a place. Frame of reference is a place. Frame of reference is a place where the observer sits and observes. Sits and observes motion or rest. Is that okay? And the third statement that you will write is, rest and motion are relative parameters. Rest and motion are relative parameters. They depend on frame of reference. They depend on frame of reference. Is that okay?
Can you repeat the frame of reference?
Yeah. Frame of reference is the place where the observer sits and observes motion or rest. Okay? For a person on moon, Earth is in motion. But for a person like us on Earth, we are at rest. Isn't it? Earth is at rest. We cannot say Earth is in motion. Because we are on Earth. The trees, the floor, you always see it is always at the same point, right? Is that fine? Okay. Now, coming to the concept of this chapter, what we will be doing is, we will be introduced to something called as kinematics, okay? Then of course we'll be studying kinematic equations. Then we will have the best example of one-dimensional motion. Best example of one-dimensional motion. That is the free fall. See? What changed?
Y-axis.
Y only. Did X change? Did Z change? No, only one changed, right? The best example. Now this example is to be considered when there is no wind. If for example there was wind, what was going to happen? Yes? This will go like this, isn't it? Or this will go like this, or something like this. So there are two coordinates which will be changing, isn't it? Or there can be even three. So the best example we talk about is free fall, but understand very important thing. Air resistance has to be neglected. Is that okay? Air resistance has to be neglected. Is that clear? That is how we will be studying the example of free fall for the motion in 1D. Is that clear? Okay. And then of course we'll be going to the kinematic graphs, and this will be something that we'll be doing along with some numericals so that we get aware of what is actually going on. Is it fine? Okay. Let us come to the next thing. Now, if we talk about do you know anything about scalars and vectors? What are scalars? Yes. Scalar is weight. They only have magnitude. Okay. Anyone else?
Vector depends on direction, scalar doesn't.
Vectors?
Depend on direction, scalar doesn't.
Yes, so they are directions. Okay. Anyone else? See, I'll tell you. Just tell me. There's a body, okay, and there are two forces exerted on this body. Each force is 10 Newton. What is the net force on the body?
0.
0. Anyone else? Yes? There is a body. I'm again repeating. There is a body. Two forces are exerted on this body.
Is it opposite sides or?
20. Anyone else? What about others? What do you think?
Depends on which side.
Yes?
Depends on which side.
Depends on which? Exactly. So like Mohit said, we cannot evaluate this question. This is not possible to be evaluated. Why? Understand, for some people, if this is the body, if this is the box, Mohit in the first case kept 10 Newton like this and the other 10 Newton like this. What is the net? 0. He was right. But then someone else kept the forces like this, and what is the net? 20. So until and unless I specify directions, we cannot come up with the result. Would you believe anything is possible between 0 to 20? Everything is possible depending on the directions. Even 1 can be the answer. We can have 2 as answer, 3 as answer, 4. These are just the extreme. This is the minimum value and this is the maximum. From minimum to maximum, everything is possible. You need to understand this. Depends on what? The direction. So there are some quantities which cannot be understood until and unless direction is given to them. Is that fine? Those quantities are called as vector quantities. Is that clear? Is it clear?
Yes.
And there are quantities which do not need direction. For example, I ask you, what is your mass? You will say 50 kg, 60 kg, something like that, isn't it? So, do I ask him, is it up or down, right or left? No. It's fixed. It is independent of direction. Is that clear? So, these quantities which do not need direction, They are called as scalars. And those quantities which cannot work without directions, they are called as vectors. Is that fine? You may write this down. You may write this down. Vectors require a direction, whereas scalars only have magnitudes. Was the example clear? Yes?
The name has been written, everyone?
Has everyone written the name? So, now what we'll be doing is, so do you get the idea of vector and scalar now? Okay. Now, when we talk about motion with constant velocity, what do you understand by constant velocity? Do you know what is velocity?
Speed, constant speed.
No.
Change of speed. Change of speed.
Change of speed? No.
Change of speed.
Yes, yes.
Speed with direction.
Speed with direction, but that direction should be
Constant.
constant, exactly. See, what does that mean? If the body is moving, for example, eastwards, okay, it's going towards east. So the direction of motion is towards east. If the magnitude of speed, if the magnitude of velocity is 20 meter per second and it is going eastwards, okay, so can I say at every point the direction is east and the magnitude is 20? Yes? If there is a body which is going from, say, west towards east, and this body is moving with 20 meters per second, okay? "20 meters per second, okay? Can I say at each and every point the magnitude of velocity was 20 and the direction was always eastwards? So both magnitude and direction were constant, isn't it? This is constant velocity. Constant velocity does not mean only magnitude is constant. It should mean direction along with magnitude, both have to be constant. Is that clear? Is it clear? Because what is velocity? Is it a scalar quantity or a vector quantity? Vector quantity. So when it is a vector quantity, it requires both. It requires magnitude, it requires direction, isn't it? So when we say constant velocity, it means magnitude should be same throughout, direction should be same throughout. Is that clear? Is it clear?
Yes.
No doubt? Okay. Now, one more thing is kinematics. See, what we are discussing is, as we discussed in the beginning, I told you, we are discussing two things. One is rest, and the other thing is, yes, motion, isn't it? And I told you, rest and motion are relative parameters, isn't it? The branch of physics which will help us to understand rest and motion is called as mechanics. What is it called? Okay? Is that fine? But this mechanics has two parts. How many? Two parts. One is kinematics, and the other one is called dynamics. Okay. When you talk about kinematics, in both the cases we'll be discussing motion and rest. Okay. But in kinematics we'll be discussing motion without understanding why a body is in motion. So the cause will not be discussed. The reason of motion will not be discussed. The reason of rest will not be discussed. We will say a body is at rest, it is or it is in motion. We will not say why it is at rest. We will not say why it is in motion. Okay? Can you tell me why a body is in motion?
No.
Because we have to apply.
Force.
So we will not be discussing anything about force in kinematics. Is that fine?
Yes.
Because force is the cause of motion, isn't it? So in kinematics, it involves, yes? In kinematics, we will be only discussing motion and rest, but without cause. We will not be discussing the cause of motion. Is that fine? But in dynamics, yes, we will be discussing the cause of motion. Is that fine? The cause of motion is, yes, force, isn't it? Force, energy, work, everything, isn't it? That is what puts bodies into rest. That is what puts bodies into motion, isn't it? So that will be discussed in dynamics. Is that fine? In kinematics, we'll be discussing motion without the cause of motion. Just understand, a body is at rest. You don't need to know why is it at rest. It is at rest. A body is moving with 20 meters per second. It is moving with 20 meters per second. You don't need to know what exactly is happening to the body due to which it is at 20 meters. Okay? You don't need to know that. So we'll be discussing kinematics today. Is that fine?
Yes.
Okay.
Excuse me?
Yeah.
Can I see?
AC?
Yeah.
Yeah, sure. Please put it on. Now see, vectors are quantities that have direction and magnitude, as already discussed. Examples are velocity, displacement, force. All of them are vectors. Scalars are quantities that only have magnitude, like mass, like temperature, like speed, like time. Okay? You know this. I hope you know this. You have studied it in grade 9, right? Okay. Okay, position. When an object is compared to some reference point, okay, that is the origin, we denote this as x in 1D and x comma y in 2D, isn't it? For example, there's a point, we have a point. This is your coordinate system, this is your x-axis and this is your y-axis, okay? Can anyone tell me how do you locate this point? First of all, don't you always speak about this origin here? Yes? With respect to origin. See, understand. For a point, this is the origin. For a body in motion, we call that space as frame of reference. Is that fine? It is the same thing. We are describing something with respect to something. So when we are describing where this point lies with respect to something, this something is called as reference point. And you call this as origin. And the coordinates of this point will be, yes, x comma, isn't it? If it was simply here, if there is a point Q, can you tell me what will be the coordinates of this point?
Q0.
Yeah, but its y will be 0, but its x will be there, isn't it? So it will be x comma 0, isn't it? So in 1D, we'll be using x for the position. Is that fine? Or we will be using only y, or we will be only using z, depending on which axis is it. Is that fine? Clear? Oh. Next. Displacement. What is displacement? Yes?
Change in position.
Change in position. Okay. Anyone else? See, my dear, all of you came from your homes to this university, isn't it? For example, this was your home. This is your home. and this is the university. Okay. All of you guys came through different routes, isn't it? You acquired, you used different paths, and then only you could reach this university. Is that fine? Some came like this. Say this is path number 1. Some came like this. Say this is path number 2. Some came like this. Say this is path number 3. Okay. The length of the actual path traveled by each person is called as? No, that is called as distance. So every individual, understand very important thing, every individual has used a different path, and therefore the value of distance for each and every individual is going to be different, isn't it?
Yeah.
It can be same as well for two people, but overall, in general, what I can say is that each and every individual is going along different paths, isn't it? Therefore, distance for each and every individual will be different, isn't it? Is that fine? But every one of you was at home and every one of you reached this university. So the net effect of motion, whatever you have done, understand, there is a very basic misunderstanding in the books. They write displacement is the net distance or the shortest distance between the 2 points. It's not that. Displacement is the effect of motion. What is it? Displacement is? It is the effect of motion. What happened? What is the consequence of motion? The consequence is you were at home, now you are at university. Is that fine? It doesn't matter what path you tried to go along, because your initial and your final position is fixed. Is that fine? And how you calculate displacement? You calculate it by calculating the distance between these 2 points, the shortest distance. That is how you do it. But what is displacement? What does it give you? Yes? It gives you the consequence of motion. Is that fine? It gives you the effect of motion. But what is distance? Yes? It gives you the path. Is that fine? So distance is the length of the path that the body travels, moving from its initial to final position. Is that fine? Distance, simple. Total distance traveled, total length. It can be different, it can be same. Some guy will have more distance, some will have less distance. Depends on the path, isn't it? So it is always what? Path dependent. It depends on the path. It depends on the route. But then you have displacement. Displacement is what? Yes, what did I say? It is the effect of motion. Is that fine? It will give you what happened. What happened was, you were at home, now you are at university. Is that clear? Clear? So for all these people, 1, 2 and 3, all of them started from the same position. They ended at the same position. What is the displacement? Yes? The effect is same for everyone, isn't it? So can I say displacement is same for everyone? Yes? Displacement, it is the effect, right? Consequence. So consequence for these 3, 1, 2 and 3, isn't it same? So can I say for each and every individual the displacement is same, but for each and every individual distance is different? Yes? Why? Because distance depends on path, whereas displacement depends on final, and because initial and final is same for everyone, displacement will be same for everyone, and because the paths are different, therefore distance has to be different. Is that clear? Yeah. Is that clear? Very important point. Very important point. Distance cannot be negative. It cannot be. Why? What is distance? Go by the definition. It is the length of the path. Can it be negative? Length cannot be negative. You came from your home to university, you are going back to your home. So the total length is double, isn't it? It's not negative. It's positive. Or it will be zero. When will the distance be zero? When you don't move, exactly. When you are at the same place. Is that fine? But when you talk about displacement, it is very important to know that displacement is the effect of motion. This effect can be positive, or there can be no effect at all, or there can be negative effect. For example, you are going around a circular path. Fine. The moment you start from one end, if you complete this circular path and come back to the original position, okay, what is your distance?
The length of the circle.
Exactly, yes. So, if you are here and you move like this and you come back to point A, what is the distance? Yes? What is the distance? if the radius is R, yes? No, it is 2 pi. It is a circumference, isn't it? Body started from A, it came like this, reached here. Because distance depends on the path. Is that clear? But at the same time, if I ask you what is displacement? It is zero. Because the effect is nothing. Nothing happened. Is that fine? So displacement in this case would be clear? So displacement is positive, it can be negative, it can be zero as well. Like for example, how can it be negative? For example, a body started from here and it moved along the positive x direction, okay? Say it was 0, no, this is 1, this is 2, this is 3, this is 4. So he started at O, now he is at B. What is his distance? 4 units, very good. What is his displacement? 4 as well, isn't it? But if after going from O to B, he tries to come back, B to C. B to? If I ask you, what is the total distance?
6.
Exactly, total distance is 6. Because see, 4 and then this 2. Shama, you are late.
Yes.
It's fine. But what is its displacement? Only 2. Why? Why? Because we will be considering initial and so this is the effect, isn't it? This is the effect. So here what you are saying is how did you actually calculate this as 2? Actually what you did was you said, sir, this is 4, O to B is 4, O to B is plus 4, but then B to C is minus 2, isn't it? Because you are going back. So see, displacement was positive, now it is negative, so overall we are having it as positive. Is that fine? Is it clear?
Yes.
Do you have any doubt about displacement and distance? This is very basic. Most of you might be knowing this, but I know when questions come, you make mistakes. So that is why I am trying to make you understand what exactly is happening. Okay. If you understood this, I'll not go to velocity and speed. I will take up this question first. How many of you have played Mario? You played it? Everyone? I used to play it as well. Would you believe it? And on a video game. Okay, so the question is, Mario drives a go-kart around a circular track with a radius of 20 meters. The question is, what is the displacement and what is the distance traveled? Yes? Yes, very good. Displacement is 0. And what about the distance traveled?
40.
Did he go and come back?
What is the question? Understand. drives a go-kart around a circular track? 2 pi, exactly. The distance is 2 pi capital R. Is that fine? And that would be equal to 2 into pi into what is the radius? 20. So it is 40 pi meters. Is that clear? Is it fine? Now understand the question. Very important question. One more question. Under what condition will an object have distance equal to displacement? Yes?
One direction.
Exactly. So we did it just now. Isn't it? We started a body at O and I told you it is going towards the x-axis and it reaches point B, which was at 4. Just we did it, right? What is the distance? What is the displacement? So understand, when the motion is around 1D, scalar and vector are equal in magnitudes. Do you understand this? What was displacement? Was it a vector? What is distance? Is it a scalar? But when you are talking about motion in 1D, when the motion is one-dimensional, you can take scalar and vector as same. Is that clear? Write it down. It is possible for a body to have same scalar and vector values when it is possible for a body to have same vector values when yes, the body is in one dimension. It is possible. Clear? Any doubt, anyone? No problems? Okay, good. If it is clear, okay, first we need to know speed and velocity. Is everyone okay? Am I too fast, too slow? We will catch up with speed, it's fine. But what I want is, if we are doing this unit, motion in 1D, some among you are going for EmSAT, okay? There will be questions which will be aptitude questions. So that is this one. If you understand it well, you don't have to prepare it, I promise you. Now let us talk about one more quantity, one more parameter in motion, one more parameter in kinematics. That is called as velocity, and then we have one more called as speed. Okay? Now if someone tells you what is velocity? Velocity is defined as the rate of change of position. Rate of change of position means at what rate is your displacement changing. Is that fine? So what was displacement? It was the effect of motion, isn't it? The question is, what is velocity? So understand what is velocity. Velocity is the rate at which motion is producing its effect. It is the rate at which motion is producing its effect. Write it down. Velocity is the rate at which motion is producing its effect. Is it fine? It is the rate at which motion is producing its effect. Or what books will say. See, understand, books have a language. But you need to understand what in practicality it is. Most of you, if I ask you what is velocity, most of you will say, sir, it is displacement, rate of change of displacement. But then you don't understand what is happening. What is velocity actually? It is the rate at which the motion is producing its effect. That means, if after 10 seconds the displacement of the body was 20 meters, in 1 second, how much would have been the effect? The total effect is how much? 20 meters? In what time? 10 seconds? Okay. In 1 second, how much would have been the effect? That is your velocity. Okay? Now because this velocity is calculated from displacement, therefore velocity is also a vector quantity. Is that fine? It will have the same direction as that of displacement. Okay? The direction of velocity and displacement is same. Is that fine? Okay? So you will calculate it as delta x divided by delta t. What is delta x? Change in position. Change in position is displacement. Delta t is change in time. Final time minus initial time. Is that fine? So that means this is final position minus initial position, and you divide this by final time minus initial time. Is that okay?
Yes.
Any doubt? So velocity, it is a vector quantity. But when you talk about speed, so whenever we talk about speed, speed is how fast a body is going. No, most of you say, what is speed? Speed is a distance per unit time. No, that is how you calculate it. That is the mathematics involved. I told you yesterday, physics is philosophy. Sir Isaac Newton never told the world that F is equal to gm by r square. No. He introduced the concept of universal law of gravitation through philosophy. He said, when the two bodies are far away, the force reduces. When the two bodies are very close, force increases. When the bodies are heavy, force increases. That is how he explained it. He did not give any mathematical equation. Mathematics is involved to make it understand, make it sound better. But physics is actually philosophy. Well, who was Newton? He was a philosopher. He was a physicist. He was a mathematician. First, you need to understand physics from the perspective of philosophy. If you understand that, I swear upon Allah, you will love the subject. This is a common, that fear among the students that we have. Physics is difficult, mathematics is difficult. The reason is we do not know what we are doing. The day you realize the importance, I told you yesterday, physics is about nature. Do you hate nature? You said no. You cannot hate physics. And I am telling you one more thing today only. Inshallah, after 6 weeks, we will be in a different mindset. I promise you that. The thing is, what we do to every action, there is equal and opposite.
Reaction.
Isn't it? If you start to love it, it will start to, it will become easy for you. This is the law of nature. It happens every time. In the morning, you are sleeping, right? A body at rest continues to be in the state of rest until and unless mobile phone alarm. External force. Isn't it? That external force was there and you woke up. A body in motion, you are sleeping, you are in the evening, you are using your mobile phones, you are not sleeping. And then all of a sudden dad knocks the door. What are you doing? And I'm like, oh God, no, I'm sleeping. So external force, otherwise a body using mobile phone continues to be in the state of using mobile phone until unless dad comes and kicks the door. What are you doing? External force, again nature, isn't it? How can you say hate the subject? It's not possible. It is, I will tell you what you hate. It is when you use maths. When you try to calculate things. But I am telling you, you love the subject if you understand the philosophy of things. Then math will become easy by itself. Is that okay? Okay. Okay, now when we talk about speed, speed is simply how fast a guy is, how fast a body is moving. Okay? How do you calculate it? You calculate it by taking distance over time. Is that fine? This will be calculated from distance. Therefore, speed is a scalar quantity. Very good. Now tell me one thing. Velocity is calculated from? I told you this displacement can be positive, negative and
Zero.
therefore velocity can be positive, negative and zero. Speed is calculated from? Distance is always? Speed will be always? Can speed ever be negative? It's not possible. If someone tells you speed of a body is minus 20, slap him. It's not possible. It's wrong. The velocity of a body is minus 20. Do you accept it?
Yes.
Yes, you should. Is that fine?
Yes.
Clear? Okay, clear. Now let us try to solve one question before I think we are. How much time is left?
5
Okay, let us try to solve this question, and tomorrow, inshallah, we'll move to acceleration. Okay. How many of you have watched Pokemon? Who was your favorite Pokemon?
Ninja.
Mine was Pikachu. Pikachu, of course. Pikachu is everyone's favorite. Pika. Huh? Okay. So, how many of you loved Bulbasaur? Have you watched Pokemon?
Yes.
Which cartoons have you watched? In Emirates, which cartoons do they usually play on the Sonic? Have you watched Sonic?
Yes.
Yeah, he's a very fast guy, right? I watched it as well. It uses concepts of physics in that movie, by the way. Okay. So the question is, what is happening?
So when you click on pen, it will go.
I'm trying to actually change the. Okay, now. Okay, see. Pikachu and Eve are both located at the origin. Do you know what is origin? It is the reference point.
Yes.
At time t equal to 0. See, what is the importance? This is so beautiful. Time t equal to 0. Allah subhanahu wa ta'ala says, if you have not prayed up till now, don't worry. Start your time now, isn't it? Everything else I'll forgive, right? Correct? Even Allah resets the button. So for Allah subhanahu wa ta'ala, whatever had happened, it doesn't matter. If from today your time starts now, time t equals 0 again. It doesn't matter what was happening in your life. It doesn't matter if you were doing any sins. Because today you repented, you said, Ya Allah, from today I'm not doing any sins. So Allah subhanahu wa ta'ala, what He does? He resets the button. Your time starts now. Time t equal to 0 doesn't mean body was at rest and now it will start in motion. No. See, have you ever heard a body was moving with initial velocity 20 meter per second? A body was moving with initial velocity 5 meter per second. A body was moving with initial velocity something, some value. Know it? Yes? What does it mean? Is it possible for someone to be already in motion? No. Everything starts from rest. First it has to be 0 and after some time it will be 20, 10, whatever, isn't it? Correct? But when we talk about some initial velocity, understand, it is actually you have started to observe it. It was going, for example, I'm looking out of this window and there's a car. The moment that you see the car for the first time, this car had some speed, isn't it? For you, time starts now. The car has some speed now. It is 20. But this car, for the guy inside the car, he switched the car on in the morning, isn't it? So it was 0. For him, the time started there only. For you, when you washed out, the time starts now. So time t equal to 0 is again it is the point from where the observer observes motion. Okay? Is that fine? So Pikachu and Eve are both located at the origin, time t equal to 0. They both start moving, both start to move. Pikachu moves with a speed of 20 meter per second, velocity of 20 meter per second, and Eve moves with a velocity of minus 10 meter per second. What does it mean? Exactly. Find the distance between the two after 10 seconds. Okay? Let us try to solve this. Can you tell me how do you approach this question? Yes.
For the first one, find the distance.
Okay.
10 seconds.
Yes.
The second one.
Mm-hmm.
Then
So what we will do is, we'll first of all draw the coordinate axis. Is that fine? This is the origin, isn't it? 0, 0. Origin, okay? From this point, Pikachu has started to go with 20. Is it towards positive x or negative x?
Positive.
Very good. So Pikachu is going here. With what speed?
20.
Isn't it? What about Eve?
Negative.
Obviously, Pikachu was always very fast, isn't it? So it is minus 10, right? Negative 10. The question is, what is the distance between the two after 10 seconds? How do you calculate distance? Do you know in which equation have we used distance? Speed, exactly. So understand, if someone tells you what is the speed of Pikachu, you have to say 10 meter per second, 20 meter per second. What is the speed of Eve? 10. Don't say minus 10. Minus means direction. Negative means direction. Positive means direction. Nothing. Magnitude can never be negative. Speed is magnitude, isn't it? Therefore, it is always positive. Is that fine? So what we will do is, we'll say speed of Pikachu is equal to distance traveled by Pikachu divided by time taken. Isn't it? Time taken is how much? We are saying after 10 seconds. So we'll divide it by 10, okay? Similarly for Eve, we have to say speed of Eve will be equal to, yes, distance traveled by Eve upon again 10, isn't it? Is that fine? So can I say which implies distance for Eve? Yes. Will it be equal to speed of Eve into 10? What is speed of Eve? Into? Very good. So the answer is? Sorry. 100 meters. Is that fine?
Yes.
Distance is positive. That means after 10 seconds, Eve is at this point and this distance is how much? 100. Is that okay?
Yes.
Very good. What about the distance traveled by Pikachu? Yes.
20.
It will be speed, that will be 20 multiplied by. So the answer is
200 meters.
meters. Very good. So that means Pikachu has traveled a distance of 200 meters. So what is the question now? Yes. Find the distance between the two. What is the distance?
300.
Very good. So the total distance is between. So Eve is here, Pikachu is here. The total distance would be 300 meters. Is that clear? Do you have any doubt? No? By the way, if someone tells you what is the displacement of Eve after 10 seconds? Displacement of Eve? Negative 100. Very good. What is the displacement of Pikachu?
200.
Plus 200. Very good. Is that clear?
Yes.
Is it fine?
Yes.
Do you have any doubt up till now? So we'll be continuing on this. Try to revise motion in 1D at your places. We'll be sharing the PDF with you as well. So that is it. Any questions? Please ask me. Thank you so much. God bless you all.
Sir, attendance.